Hello everyone. Let me begin with something you do every day, walking. Have you ever thought about how you are able to move forward? You push the ground backward with your foot, and surprisingly, the ground pushes you forward. This is the beauty of Newton's third law of motion. The second law told us how force causes acceleration. But what is the origin of this force? Where does it come from? Newton answered this with his third law: every force is always the result of an interaction with something else. As you press on a spring, it presses back on you with equal strength. Even when the earth pulls you down with gravity, you are actually pulling the earth upward with the same force, only the earth's huge mass makes its motion imperceptible. Newton's statement is simple yet profound. For every action, there is an equal and opposite reaction. That means forces always occur in pairs. If body A exerts a force on body B, then body B simultaneously exerts an equal and opposite force on body A. Symbolically, we write F sub A on B equals minus F sub B on A. So if you push a wall with 50 newtons, the wall pushes you back with exactly 50 newtons in the opposite direction. Now, students often imagine action and reaction as cause and effect, first action, then reaction. That's not correct. Both forces exist together at the same instant. Also, these forces act on different bodies, never on the same one. That's why they don't cancel out. When you push the ground while walking, the action is on the ground and the reaction is on you. If both acted on you, you'd never move. This law is all around us. Times in swimming, your hands push the water backward and the water pushes you forward. Times in rocket launches, the exhaust gases are pushed downward and the rocket is thrust upward. Times in gun recoil, the bullet is pushed forward and the gun jerks backward. Let's look at it mathematically. If force on body A by body B is F sub A B, then the force on body B by body A is F sub B A. Newton's third law says F sub A B equals minus F sub B A. These two forces are equal in magnitude, opposite in direction, and act on different bodies. Internal forces within a system always cancel, but the external force is what produces motion. That's why rockets move forward even in the vacuum of space. They push gases backward, and gases push them forward. Let's solve a quick example. A batsman hits back a cricket ball straight toward the bowler. The ball has a mass of 0.15 kilograms and speed 12 meters per second. What is the impulse imparted? Step 1. Initial momentum equals 0.15 times 12, which is 1.8 kilogram meter per second. Step 2. Final momentum equals negative 1.8, since the direction is reversed. Step 3. Change in momentum equals final minus initial, that is negative 1.8 minus 1.8, equal to negative 3.6 kilogram meter per second. Step 4. Impulse equals change in momentum, which is 3.6 Newton seconds opposite to the ball's motion. So the bat applied an impulse of 3.6 Newton seconds to reverse the ball's direction. Let's wrap up. Newton's third law tells us that no force exists alone. Every force comes with a partner, equal in size but opposite in direction. These forces act on different bodies and occur at the same time. Walking, swimming, rockets, and gun recoils all are living proofs of this elegant principle. So to sum up, for every action, there is always an equal and opposite reaction. I hope you now have a clear understanding of how this law explains not only simple movements but also grand events like rocket launches. See you in the next session with another fascinating concept of physics.